Hello everyone, welcome to new class. Today's class is the problems related to Routh Hurwitz Criterion. That is the problems related to stability analysis. So let us go through the problems. Using Routh criterion, determine the stability of the system represented by the characteristic equation s raised to 4 plus 8s cube plus 18s square plus 16s plus 5 equal to 0. Comment on the location of the roots of characteristic equation. So, here the characteristic equation given is s raised to 4 plus 8s cube plus 18s square plus 16s plus 5 equal to 0. And here the order of the equation is 4. So it will have 4 roots. So number of roots is equal to 4. That is highest power of s is the number of roots. So there will be 4 roots and we have to construct the Routh array. So for that, first of all, write the highest power of s, that is s raised to 4. Then the coefficients of even orders we have to write. So the coefficient of s raised to 4 is 1. Next even order is s square. So it is 18. Then next even order means here s raised to 0 is there. So its coefficient is 5. Now we have to write next highest power of s, that is s cube. And the coefficient of s cube is 8. Next odd number of s is s raised to 1, that is, and the coefficient is 16. So we have to write 16 here. And here no coefficient, that means it should be considered as 0. And no need to write 0 here. Now next power of s is s square. And we have to find the coefficients or elements of this row. For that we have to consider the above 2 rows, and the first element of this s square is product of these two minus product of these two divided by this element, that is 8 into 18 minus 1 into 16 divided by 8. And for simplicity, here this row we can divide by 2. That is, while dividing this row by 2 by 8 we get, so here s cube we can rewrite, that is here we get 1, then 8, 1 and 2. So this is s cube. Now s square we have to find. So here we can write as, and here we have to consider these 2 rows, that is 1 into 18 minus 1 into 2 divided by 1. So we get 18 minus 2 divided by 1, that is 16. And next element is obtained like this, that is 1 into 5. 1 into 5 minus, here we have to consider this as 0. 1 into 0. 1 into 0 divided by 1. That is equal to 5. So this is 5. Next is s raised to 1. And s raised to 1 is obtained with the above 2 rows. So these 2 rows we have to consider, that is 16 into 2. 16 into 2 minus 1 into 5 divided by 16. And it is approximately equal to 1.7. So we can write here 1.7. And next element is obtained with the next 2 elements. So here no elements, so this is considered as 0. Next is s raised to 0. S raised to 0 is obtained as 1.7 into 5 minus 16 into 0. 16 into 0 divided by 1.7. So it is obtained as this element, that is 5. Now we have obtained the Routh array. So this is Routh array. Now we have to examine the first column of this Routh array. And here, while observing the first column, all the elements are positive. That is, here all the elements of this first column are positive and there is no sign change. Hence, all the roots are lying on the left half of S plane and the system is stable. So, the system is stable and all the four roots are lying on the left half of S plane. So this system is stable because in the first column of this Routh array we get all the elements as positive. Let us do another problem. Find out the stability of the system given by the characteristic equation 9s raised to 5 minus 20s raised to 4 plus 10s cube minus s square minus 9s minus 10 equal to 0 by using Routh criterion. So this is the characteristic equation given and we have to construct the Routh array. So here the highest power of s is s raised to 5 and it is odd number. So we have to write all the odd number of coefficients. That is, first one is 9, then 10, next is minus 9, next highest power is s raised to 4 and its coefficient is minus 20, next is minus 1, next is minus 10. Now we have to calculate s cube and s cube is obtained minus 20 into 10, then minus of minus plus, that is plus 9, that is 9 into 1 divided by minus 20 and that is equal to minus 200 plus 9 by minus 20 and that is minus 191 divided by 20. So minus cancelled and we get approximately equal to 9.55. So here it is 9.55. Next element is obtained like minus 20 into minus 9, that is 20 into 9 minus 9 into minus 10, that is plus 9 into 10 divided by minus 20 and that is equal to, here this 9 can be take outside. Also 110, that is 90 into 2 plus 1 divided by minus 20, and that is equal to 9 into 3 divided by minus 2, that is minus 27 divided by 2, or we can write minus 13.5. So it is minus 13.5, and next element is 0. Either we can write 0 or no need to write. Then next element is s square. So s square is obtained with the previous two rows, that is 9.55 into minus 1, then minus 20 into minus 13.5, that is minus 20 into 13.5 divided by 9.55, and that is equal to, we get it as minus 29.3, that is minus 29.3. Next element is 9.55 into minus 10, 9.55 into minus 10 minus 20 into 0 divided by 9.55. So we get it as this minus 10. Next element is s raised to 1. S raised to 1 is obtained minus 29.3 into minus 13.5 minus, that is minus 29.3 into minus 13, that is plus 13.5 minus of minus, we get a positive. Then 10 into 9.55 divided by this minus 29.3, and we get it as minus 16.8. So minus 16.8, and next element is 0. Next is s raised to 0, that is minus 16.8 into minus 10 minus 0 divided by minus 16.8. So we get minus 10. And here, while examining the first column of this Routh array, we can observe that there is sign changes. So first sign change is, this is plus to minus. So here one sign change is there, that is plus, minus, again plus, then minus, minus, minus. So this is the sign changes here. So while observing, we can find that plus to minus is one sign change. Then minus to plus is another sign change. Then again plus to minus, another sign change. So there are three sign changes. So three sign changes there. So these three roots lie on the right half of S plane. So three roots lies on the right half of, three roots lie on the right half of S plane, and the total number of roots are, the highest power of S is 5. So there will be 5 roots. 5 roots are there. Out of these 5 roots, 3 roots lie on the right half of S plane, and the remaining 2 roots lie on the left half of S plane, and the system is unstable. because there are sign changes in the first column of this Routh array. The system is unstable and 3 sign changes are there. So 3 roots lie on the right half of S plane and the remaining 2 roots lie on the left half of S plane. So this is about the problems related to the Routh criterion, and more problems will be done in the next classes. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.